In a world where math is lacking, 3 people can save it.
M squared.
M cubed.
And M to the 4th. We are the 3 Mathketeers.
Arin, I heard John doesn't know how to simplify radicals.
What? That's a job for M to the 4th. Is it true?
Yes, M to the 4th. It's true.
Okay.
I cannot simplify radicals.
I'm here to teach you about simplifying radicals. First, you see if any perfect square factor other than 1 goes into the radicand. Do you understand?
I do.
Good. If so, write the original radicand as the product of this perfect square factor and the other factor it would need to maintain equivalency. You with me so far?
Yes!
Good.
M to the 4th.
Third, square root what you can. Yes. Step 4, repeat if necessary. If not, then you have your answer. Would you like me to show you an example?
Please demonstrate M to the 4th.
Okay. John.
M to the 4th.
Thank you. So, here we have a classic example of how we need to square root an even power and an odd power that are inside the radical, and a coefficient. So, we're going to take the 2, bring it down, because it's outside of the radical, and
We don't mix our outsides and insides.
No. But we can break up 8. So we're going to, what will we break that up into?
7 plus 1?
No, 4 times 2.
You have to break it up into factors.
Yes. Then, because P is an even power, we're going to bring it down. So P to the 2nd. Then, because Q to the third is an odd power, we're going to break that up into Q to the 2nd, which is now an even, and Q. Understand?
Yes.
Good. Then, since R is just R, we're going to leave it as it is. We're going to take the 2, bring it down again. So now, we're going to take all the perfect squares and put them in their own separate radical. And then we're going to take the not perfect squares and put all of them together in one radical. Okay? Let's do it. So 2 to the 4th, and we're not bringing down that 2 because that's going to go in our separate radical with the not perfect squares. Then we're going to do P to the 2nd, and then Q to the 2nd, because those are both perfect squares. Now, we're going to do square root 2 PUR, because those are all the not perfect squares. Now, we take everything here and put it on the outside of our next radical, and then take the inside and put it on the inside. 2 times 2, because the square root of 4 is 2, times P Q. Now what we just did, in case you didn't know, was we took the square root of 4, which is 2, P, which is P squared, which is P, and Q squared, which is Q. Now, we take this and move it here. So, 2 Q R. But we're not done yet. We take 2 times 2, which is 4, 4 P squared, square root sign, 2QR. And you have your answer.
Outstanding.
Yay! I'm here to help you. We're going to simplify radicals. Yay. For the second problem, we're going to do 3 radical 72 x to the 8th, y to the 11th. So now, Gaby, please. We bring down the 3, because it's on the outside of the radical, and square root 36 and square root 2, because we're breaking up 72, because we can break it up into 36 and 2. Okay? Cool. Because it's not a perfect square, so you have to break it up. Then we do another radical, and that is a perfect square. So we could break it down and just put x to the 8th. Just break it down. And then y to the 11th is an odd power, so it's not a perfect square. So we have to break that up into 2, which would be y to the 10th, y. Because y to the 10th plus y is y to the 11th. Understand?
Got it.
Okay. So now we can, 36 is a perfect square. So we bring down the 3 again, times 6 rad 2. There is no radical sign before the 6. Because 36 is a perfect square, we're square rooting. Then we do times x to the 4th times y to the 5th rad y. Now, we're doing this because x to the 8th is a perfect square, so we're breaking that up into x to the 4th. Then, we're doing x to the 5th because you can take that from y to the 10th. But y is not a perfect square, so we have to bring that down. Now, we take everything outside of the radical, so that would be this, 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 and so now we do 3 times 6 is 18, x to the 4th, y to the 5th, so we're bringing all the things outside of the radical to one side, then rad sign, 2, and y. And there you have it! Your answer!
That's my answer.
Do you understand?
Totally. You have saved the world, Arin. And to the 4th. And to the 4th.
Yay! Okay.
Darn it!
Miss King, what's wrong?
I don't know how to simplify radicals!
Well, I know who does.
You don't know how to simplify radicals?
No!
I'll help you!
Yay!
Okay, for the third example, we're gonna do 6 square root 75 m p to the 2nd q to the cubed. Now, you bring down the 6, because 6 is a perfect square. Square root 25 square root 3, because 75 isn't a perfect square, so you have to break it up into 25 and 3. Do you understand?
Yes.
Now, since p to the 2nd is a perfect square, we're going to just bring it down, p to the 2nd, times, we have to break up q to the 3rd because it's not a perfect square. So we're going to break it up into q to the 2nd, q. Because q to the 2nd plus q is q to the 3rd. So now, we're going to bring down the 6 again and take the square root of 25 because it's a perfect square. So that's times 5. 3 is not a perfect square, so we're going to keep that in the radical. Times p, because p squared is perfect square, so we're going to bring down just p. Same thing with the q, just q. And then since that is not a perfect square, since rad q is not a perfect square, we're just going to bring down the rad q. Now, we have to multiply 6 times 5, which is 30. And then we're going to add the two things that aren't inside a radical to right here. So it's going to go outside the radical with this, 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 and this. So then you do rad, and then you're going to add the things that are inside the radical. So 3q. And that's your answer. Do you now know how to simplify radicals?
I do!
Yay!
Hey guys. Gab, what's up? What are you doing?
I'm doing my math homework.
What are you doing? What's it about?
It's about SOHCAHTOA.
Huh?
Do you not know how to SOHCAHTOA?
I know how to soak my toe, but
Sit
I
down,
don't know
I'll
what's
teach
that.
you.
Oh my gosh. You mean I'm going to learn something new
Yeah!
at my age? Okay. Show me.
Oh, okay. First I'll teach you what SOHCAHTOA means. Okay. So,
I'm ready.
SOHCAHTOA. Ladies and gentlemen. Okay, so, in trigonometry, we know that in triangles, the sides are proportional to the angles opposite them. So that's where SOHCAHTOA comes into play. So.
Speak English.
SOHCAHTOA.
Okay.
So.
I see that.
Yeah. Okay. So.
I don't know.
Okay. So this right here,
Mm-hmm.
the SOH, stands for sine, which is opposite over hypotenuse in a triangle. So then the CAH is cosine, which stands for adjacent over hypotenuse. And then the TOA stands for tangent, which is opposite over adjacent.
Okay, I
Got
got
that?
you so far.
Okay, so I'm going to show you how you find sine, cosine, and tangent in a triangle. Okay? Okay. So let's say you want to find tangent for this one. So tan stands for opposite over adjacent. So let's say we want to find angle A. That's B, that's C.
Okay.
Right, so this is 30, say, and this is 16, and this will be 34. So, opposite angle A is 30, so we would write tan A equals 30, and then adjacent over angle A is 16, so it's 30 over 16. So, we found the tangent, which is 30 over 16, but you can simplify that. So the final answer would be tan A equals 15 over 8. Boom.
Wow.
Shabam, that's how you find tangent. Okay, so I showed you a triangle where you find tangent. Now we're going to show you a triangle where you find cosine.
Okay.
Well, let's go over, guys. Cosine or cos equals adjacent over hypotenuse. So.
Okay, let's see the triangle.
Here's a triangle. Let's say we want to find angle C. This will be A, this will be B. So this will be 15, this will be 9, and this will be 12. So, cosine C is adjacent. It's 12, is adjacent from the C. And then hypotenuse is 15. This is always the hypotenuse. So that's it. Yeah, because you can't simplify it.
Wow, that was easy.
Sine! We're finding sine.
Oh, goody!
Woo! Okay, sine is opposite over hypotenuse. So, 20. This will be 12. This will be 16.
And what are we looking for?
So we're gonna
Sine of
find
what?
sine z. That's z. This will be y. This will be x. So opposite over hypotenuse. So sine z equals, what is opposite the angle z?
12?
Correct.
Oh, I got it. I'm so excited.
So now, what's the hypotenuse?
20.
Yeah!
I'm right. Oh, good.
So, but you can simplify this. So, when it's simplified, it comes down to 3 over 5. And that's your answer.
Wow.
So,
Oh, boy.
we found, I showed you where you can find sine, cosine, and tangent.
Correct.
But there's also where you can use sine to the -1, cosine to the -1, and tangent to the -1. And you use those if you want to find the angle.
Why do I want to do that?
Because if there's a missing angle, you need to find all the angles of a triangle. Gosh, no. Okay, so let's say
Jeez, rough teacher.
I give you this triangle. You don't know what this angle is. Oh my gosh, what are you gonna do? But you do know this will be angle A. Hold on, this will be angle B. This will be angle C.
Mm-hmm.
And this will be
You gotta give me something.
55, and this will be 51. What do you know in this triangle that can help you? This is
Opposite
yes.
over
this is opposite.
hypotenuse.
Yes. What is that?
And that means the sine.
Yes.
Oh, I got it right.
Okay. So use theta when you don't know what the angle is.
Gotcha.
So the opposite, which is 51, over 55. Okay. So then you take both sides and you multiply it by sine to the -1. Same with this side. So then the sines cancel out because you want to get theta all by itself. And then when you take the sine to -1, you know, with this, you get 68.01. Yeah.
Oh my
And that's
God!
what angle A is.
That's amazing. Just amazing.
Thank you. Obviously, if you want to find cosine and the tangent of theta, you would use cosine to the -1 and tangent to the -1. It's the same steps to get your answer.
Oh, wow. You're really smart.
Oh, yeah.
That's
Please.
amazing.
So now, I'm going to show you how to find the side of a triangle using sine, cosine, or tangent. So here's your triangle. And, okay. Say. So this is the side that you don't know and you want to find that, right? So,
Hence the letter X.
yeah, hence, yeah, X. So,
How do we find X?
So, this is opposite angle 46.
Mm-hmm.
So, and it's hypotenuse. So, what is that? Sine, cosine,
Opposite
and
over
tangent.
hypotenuse
Mhm.
is sine. I did it. I got it right.
So, it would be sine 46
You're
equals,
a fabulous teacher.
oh, thanks, equals 8 over x. So now you put this over 1 in order to cross multiply.
Mm-hmm.
So, sine 46
X.
times x, sorry, equals 8, because 8 times 1 is 8.
Mm-hmm.
So now, you divide by sine 46 on both sides. Because you want to get x by itself. Your answer will be
Dun, dun, dun.
11.12. And that's what x equals.
Wow.
Yeah.
I'm blown away.
Okay, and that's how you SOHCAHTOA once.
What if you have to SOHCAHTOA not once, but twice?
I'll save you.
Oh, I'm so glad because I was worried I wasn't going to figure that out.
Let's get learning.
I'm ready.
Hello.
Hi, Ben.
So yesterday, you learned how to SOHCAHTOA once.
Oh, yeah. That was fun.
So now I'm here to teach you how to SOHCAHTOA twice.
Wow, I didn't know you could SOHCAHTOA twice.
Oh, if you can SOHCAHTOA once, Mom, you can SOHCAHTOA twice.
All right, I'm ready to go.
So here we have our triangle.
Hi.
Okay, so in order to do SOHCAHTOA, we need to divide the triangle into two triangles. So we have a right angle, as you can see here. So we have our side length here, which is 9, but we need to find out this side, which is x.
Okay.
In order to do so, we need to find out what this side is.
Oh, this looks complicated.
It's not, Mom, trust me. So we're going to start with our angle 35. We're going to take the 9 and the y in order to find out what this side length is, which is sine, cosine, or tangent.
I think you just helped me figure out that it's tangent.
Why?
Because it's opposite over adjacent.
Good job.
Oh, thank
So
you.
in order to set up our problem, we have tan 35 equals 9 over y, our opposite over our adjacent.
Got
In
you.
order to solve for y, we are going to set tan 35 over 1 and cross multiply. And you get your result is tan 35y equals 9. Now we need to get y all by itself. So we divide both sides by tan 35. So these two cancel out. And when you plug it into your calculator, you would get y equals 12.9. And then that's your side length for this one.
Wow.
So now we need to find x, this side. So we're going to take our other triangle and take our 61, set it to our x and our y. Do you know what that is?
Isn't that the same thing? A
Good
tangent
job.
also?
Yes, it is tangent, which is our opposite over our adjacent. So
So it's...
we are going to take our tangent of angle 61 and equal it to x over 12.9, our opposite over adjacent.
Gotcha.
Same thing, we're going to set it over 1 and cross multiply. And you're going to end up with tan 61 times 12.9 equals x. Because x is already by itself,
Yeah, how do you do
we
that?
just multiply tan 61 by 12.9. And we will get 23.3 equals x, and that is
so
your
that's...
side.
Oh my gosh.
And that is how you SOHCAHTOA
Twice. Wow, that's pretty amazing.
Okay, so now that you know how to SOHCAHTOA twice,
Yeah.
you can now find the area of a triangle using multi-step SOHCAHTOA.
Wow.
So, we have our triangle here, and we have angle 50 and angle 65. One base of 41. So you see we divided it again into two triangles, so we only have one base. We need to find the other base, which is this side, and we need to find the height, which is this.
Okay.
So we have to find the area of the triangle. So we're going to take our angle 50, we're going to set it to our 41 and our y, which is what?
Opposite over adjacent again?
Yep. So we're going to take tan 50
Wow.
and set it equal to 41 over y. Tan 50y is equal to 41.
Okay.
So we have to get y all by itself.
Right.
And we divide both sides by tan 50. And
So
we get...
one side cancels out.
Yeah. And we get 1 equals 34.40. That's our height.
Okay. That's that part.
Yes.
Okay.
So now we need to find the other half of the base. So we're going to take our angle 65 and multiply it with our base and our height. Do you know what those are?
Okay, so again, it's opposite over adjacent, so that means you use the tangent another time.
Very good. So we take our tan 65 and set it equal to x over 34.40, which is our base, which we need to find out,
Okay.
and our height, our opposite over
Which we
adjacent.
just found out.
So we're going to get tan 65 multiplied by 34.40 equals x. X is already by itself, so all you have to do is just multiply the tan and your number.
Oh.
So you just get 73.77 equals x, and we found our other base. So now that we have the bases and the height, we can find the area.
Okay.
The formula for the area of a triangle is A equals 1/2 base times height.
Oh, that should be okay. All right.
So we're going to take A equals 1/2 times 41 plus 73.77, because we have to add both of them together, times our height, which is 34.40. And when you multiply it in your calculator, you get 1,974.404 square units, and that's your area.
Wowee. You're really smart. You know lots of stuff.
Thank you. I know. For our last problem today, I'm going to teach you how to find the area of a triangle again, but plot twist, it's a different formula for a very special triangle.
What kind of triangle is it?
We classify it as a side angle side triangle, which is when you have a side, an angle, and another side.
Sounds like a dance move.
It's not.
Okay.
It's basically when you just have an angle in between two sides. Side, angle, side.
Okay, so what do we gotta do?
The formula for this particular triangle is A equals 1/2 AB sine C.
Oh, that sounds complicated.
So all you have to do is take 1/2 of your times your two sides, 8 and 6, times the sine of your angle, 67. And all you have to do is plug it in your calculator, and your total answer is 22.09 square units, and that's your area.
Wow, that one was easy.
Yes, it was. Yes, it was.
You know, you really know this stuff really good.
I know I do.
You guys must have a really great math teacher.
Love you, Miss Newborn.
So now, we do 3 times 6, which is 18.
Is this a class?
They're teaching me radicals.
Are you subbing?
Math project.
Who's on the other side of this
No
Skype session?
one.
We're just recording?
Yes.
I feel like I'm on the real world in the confession room.
They have no
I
idea.
can't take living in this house. It's making me crazy. I mean, all these people. You never watched The Real World?
Nope.
Created by Mary Ellis Bunham?
Nope. They
Are you
have
kidding?
0 reference points. Very sad.
I was actually looking for the two of you, but I don't really know what this is. Is this a free period, or you?
I am free, giving up my precious free
I'm
time
almost done!
to learn about radicals.
It's for our math.
I thought that means shorish.
Would you like to join us? Would you like to? I have to.
No, I have
finish-
to have a quick word with the two of these guys.
Okay.
But I don't want to take them out of class, and I can't tell what this is.
This is a class.
Who's the,
They're
who's
in
the
the
teacher?
middle of a math class. You're in math, right?
Yes.
They're working on
So-
a project in math.
Let's just finish this really quickly. So you do 3. Guys, I need to save the world here. She doesn't know how to simplify radicals.
I don't. Because I don't care
Rabbi
either.
Pell, do you know? Do you know how to simplify radicals?
I've forgotten almost all the math.
So you could be
other,
our-
other than what I need to do budgets and
He can't
spreadsheets.
simplify radicals. I'll teach
Did you
him.
guys bring anything to school for me today?
Okay. Ready? I'm gonna finish.
Finish, please, because I got to go back to my work.
3 times 6 is 18. So then.
Sorry to interrupt, by the way, or the video, or I don't know, somebody in China who's watching, or I have no idea what's going on here.
Oh my gosh.
That's my answer.
Do you understand?
Totally. You have saved the world, Arin.
M to the 4th.
M to the 4th. M to the 4th.
Yay!